So hello guys, I'm back with another interesting video. Today I'll be showing an simple neural networks algorithm that we'll be using on an Snake Xenia app. So to do that, I'll be using an open source software called the Processing 3. You can download it from the GitHub and I'll leave the link in the description. Here's the code that I've written, and also the neural networks algorithm is included in this. This is a Java program. So here the program is very simple. A Snake Xenia game, that is, if the snake touches the wall or the tail of itself, that's the end of the game, and the score increases as the snake consumes the balls, the red balls you can see over here. So on the left side, this is the basically game over here, and on the left side you can see the neural networks diagram. So here each snake contains a neural network, and basically it has 24 neurons at the input and 4 neurons at the output side, and there are 2 layers of 16 neurons of the inner layers. So the output, as told, it has 4 outputs, basically the visions of the snake, that's up, down, left and right. So the basic calculation of the neural algorithm that we'll be working on is with the distance from the foot, or the red dot that you can see, distance to its own body, and the distance to the wall. So these are the basic 3 things that the snake will be calculating at each instance of the time. Next is the what is the algorithm that we are using. Basically for games such as this kind of the Flappy Birds, we'll be using genetic algorithm. Genetic algorithm is nothing but is an evolutionary algorithm, that is, at the very beginning it would be a very, and as we continue with generations, it will delete or add some features, and you can also here save the model at each generation whenever you want. And also you can see the mutation rate. You can increase how many features to add or delete at each time, at each generations. I'll just fast forward it here, and it's already reached the generation 2. So yeah, compared to the Gen 0 and Gen 1, it's doing quite better, and in Gen 3 it's doing much better. So you can also observe the graph over here, the y and x axis showing the generation with and the score that the snake is scoring at each generation, and the graph is showing that it's gradually increasing. So it's still in the Gen 3, and by Gen 10, Gen 50, or by Gen 100, the snake can do really better. Or there would be a gen after which the improvement or the mutation is actually very low, and that's where you can end the training the model. It's still increasing, so we'll just continue training this snake, and Gen 8 and Gen 9 really wrong. I had to skip those generations, and now in Gen 10 there was a sudden rapid improvement in the snake, and in Gen 17 the snake started to survive for much longer time than the previous generations. And in Gen 19 there was a huge improvement in the snake, and I'll just fast forward to around Gen 31, and you can see the snake is now at its best, and it has evolved to the best. And after this you can see or observe in the graph that is just a very slight improvement, and this way you can stop training the model. So that was a quick walkthrough a simple neural networks program. Thank you.